Now, what is ideal op-amp? As we have already seen that there are several parameters, that is input resistance, output resistance, gain, etc. So there is one op-amp which is known as ideal. It should follow some properties. First one is open loop gain. Open loop gain A should be infinite. That open loop gain A should be infinite. Second one, that input resistance Ri should be infinite. Third one, that output resistance Ro, it should be 0. Now input resistance is infinite, means open circuit. So that's why op-amp input current will be 0 for ideal case. Output resistance is 0. Output resistance 0 means it will not drop any output signal across it. So you can drive any amount of source through it and it will not load the op-amp. Fourth one is bandwidth. Bandwidth of the op-amp should be infinite. You know there will be AC signals, low frequency signals as well as high frequency signals. It is desirable that it can amplify any frequency signal. So that's why for ideal op-amp bandwidth should be infinite. Fifth one is common mode rejection ratio, CMRR, should be infinite. So common mode rejection ratio is the ratio of the differential gain by the common mode gain. So CMRR infinite means common mode gain will be 0, differential gain will be infinite. So but that is desirable. So there should be no common mode gain for the op-amp, ideal op-amp. Number 6 would be the slew rate. Slew rate, it should be infinite. Slew rate defines the rate of change of the output signal. So slew rate infinite means output can change at any rate, very high rate, infinite rate. So there will be no distortion for this for the ideal op-amp, as there is slew rate infinite. Now practically we may not get these values. So these are the ideal values. So practically this op-amp gain is very high, and typical value is around 2 into 10 to the power 5. It is 2 into 10 to the power 5, around order of 10 to the power 5. Ri cannot be infinite practically, but practically we achieve Ri, that practical op-amps having at least 2 mega ohm of input resistance. Ro, it may not be 0, but Ro can be around 75 ohm practically. Bandwidth is not high, but you can achieve bandwidth maybe up to order of megahertz. So you can amplify maybe megahertz up to megahertz signals, and it depends on the vendor company which fabricates the op-amps. Slew rate infinite is not possible, but it can be around 10 dB. Sorry, CMRR should be would be 10 dB. And slew rate we measure volt per microsecond. Slew rate infinite we measure volt per microsecond, and typical op-amp have slew rate 0.5 volt per microsecond. That means in a microsecond output can change maximum 0.5 volt. So these are the ideal op-amp properties. Now there are different op-amps available in market. Among these we use IC741 for this course. So we'll use IC741 op-amp for this course. It is an IC, 8-pin IC. it is an 8-pin IC. Here you have a notch, or sometimes you may have a circle here. So 1 2 3 4 this side, and another side having 1 2 3 4 pins. So that will be pin number 1 2 3 4 5 6 7 and 8. Now, as we have already seen that op-amp have two inputs, one is inverting input, another one is non-inverting input. So pin number 2 is the inverting input. So pin number 2 is the inverting input. Pin number 3 is the non-inverting input. And output is pin number 6. Now for the op-amp you need power supplies. So pin number 4 will be negative power supply minus VE. Pin number 7 will be plus VCC, positive power supply. Generally we use plus 5 volt and minus 5 volt, or maybe plus 12 volt, minus 12 volt, depending on our circuit. Now pin number 8, it is only provided for the symmetry purpose. So this side have 4 number of pins, so that side should have 4 number of pins, or maybe in future development there may be an extra pin required, but this op-amp IC741 don't have any connection of the pin number 8 within the circuit, so it is no connection. So this pin is not connected internally. Now there are two extra pins, pin number 1 and 5. These pins are known as offset null. So there are some offsets present, input signal, input current and voltage offsets, and this offset you can nullify using pin number 1 and 5. Now we'll use op-amp in real circuits. So first we'll use a open loop operation. So in open loop operation you have op-amp, you have two inputs, V1 and V2, and your output is V0. Difference of these inputs is Vd. As we already know, V0 equals A into Vd. If I consider RO is 0, if I consider output resistance RO is 0, if I consider RO is 0, then we can write V0 is equals A into Vd. And Vd equals V1 minus V2. Now see, if I consider it is an ideal op-amp or a practical op-amp, A is very high. So a millivolt range, maybe A equals maybe 10 to the power 5. A equals 10 to the power 5. And Vd is the difference, which is maybe 1 millivolt difference. So V0 as a result will be A into Vd equals 10 to the power 5 into 10 to the power minus 3 equals 10 to the power 2 volt equals 100 volt. Now see, a small 1 millivolt input difference can create an output which is 100 volt. Now if I assume that op-amp is driven by the power supply that is minus 12 volt and plus 12 volt. So op-amp power supply is minus 12 and plus 12. You see that is the voltage supplies, and output cannot exceed the plus 12 volt, or output cannot be below minus 12 volt. So output will be within the plus minus 12 volt. So you cannot get output as 100 volt, because maximum output is possible which is 12 volt. So output will be 12 volt. However, in practical cases, you can see that if that is 12 volt and minus 12 volt, output cannot attain maximum 12 volt, it may be 11 volt or 10.5 volt. So output, maximum output can be 10.5 or 11 volt. So that will be the range, which is known as maximum output voltage, is known as saturation voltage, which is known as Vsat. So output will be either plus Vsat or minus Vsat. So output V0 can be either plus Vsat or minus Vsat, depend on the inputs. So in this case, your output want to be 100 volt, but before that it cannot, it don't have the enough supply voltage, so 100 volt cannot be attained here. So as a result, output will be Vsat plus Vsat. If the difference is negative, output will be minus Vsat. So that's why you see, due to the very high open loop gain, we cannot use the op-amp directly to amplify a signal. So we need to do some alternate method to amplify as we require. So suppose we need amplification factor 5. So we need to use op-amp in such a way that it can produce only 5 gain. Another thing, the name behind the inverting and non-inverting terminal, why it is known as inverting terminal and why it is known as the non-inverting terminal. Now see, to do this, let us assume that this same op-amp, which is having gain A, that non-inverting terminal is grounded, and inverting terminal you have a sine input. So your difference voltage is this 0 minus this. So Vd will be, so maybe that is V1, maybe V1, and that is 0 voltage. So Vd will be minus V1, because Vd is the difference between this and this. So 0 minus V1 will be minus V1. So V1, we already know V1 is a sine wave. So Vd will be, that is V1, and Vd will be just inverted version of the sine wave. Vd will be inverted version of the sine wave, and output V0 will be A times Vd. Let's consider that A is finite and output is within the range. So output will be minus A into V1. So that's why you can see output will be inverted. As you can see, the input signal applied at the inverting terminal and output signal having 180-degree phase shift, 180-degree phase relation. So that's why it is known as the inverting terminal. So phase difference between output and this input is 180-degree. Similarly, you can see if I do the same task, that is inverting terminal is grounded and non-inverting terminal have V1, output V0, then you can see, and gain is A, op-amp gain is A, then if I apply a sine wave, you will get sine wave at the output side with same phase. Here we are not considering the amplitudes. Amplitude can be anything. We are focusing on the phase. So phase relation between output and non-inverting terminal is 0 degree, and phase difference between output and inverting terminal is 180 degree. So that's why one is known as inverting, another one is known as the non-inverting terminal.